Hello, this is the second part of the embedded Linux for Zynq 7000 and Zynq Ultrascale Plus lesson. In today's video, I will teach you how to use Buildroot tool for building Linux kernel, for building device tree, and rootfs file system. Before we start, I would like to remind you what we already considered from our previous lessons. So we learned how to build first step bootloader, how to build bitstream, PMU and untrusted firmware for Zynq Ultrascale Plus, how to configure and build a second bootloader. So all these files, it's just a part of image that we need for booting Linux for Zynq 7000 and Zynq Ultrascale Plus. So today we will consider how to build remaining files for our image. These files are kernel, it's a kernel itself, device tree, and rootfs, it's a file system. For building all these files, I will use Buildroot with out of tree. Out of tree means that we will have Buildroot sources, we will have customization files, and we will have output files in different directories. It's very convenient because in this case you just have to keep your directory with customization settings, and every time when we need to build all these files, you just will download Buildroot sources and create a folder for keeping output files. While considering Buildroot, I will use Buildroot manual. So I recommend you to look at the Buildroot user manual. It's very useful, and especially it's a chapter 9, project specific customization. So what is Buildroot and what kind of files we are going to get by using Buildroot? By using Buildroot, we are going to get compiled kernel, we are going to get binary device tree, and archived rootfs file system. All these files will be combined into one file. It's an image ITB file that will be added to our files that we considered in our previous videos. Okay, so let's start. I will start from folder where I'm going to build, where I'm going to keep all additional directories. It will call Linux image. Okay, and Linux image. Okay, so first of all, we have to clone Buildroot sources. Okay, so it takes several minutes. Okay, so it's done, and let's check. Okay, so here we have a directory with Buildroot sources. I will create 2 additional directories. First directory, it's the directory for our output files, and another directory, it's a directory Zynq external, and second directory, it's a directory where we'll keep our customization files. Okay, so again, Buildroot will use settings from customization folder, and we'll build Linux image that will be stored into our tmp folder. Okay, then let's move to our customization folder Zynq external. Okay, and here I am going to use the Buildroot, the Buildroot user manual. It has recommended directory structure, and I recommend you to use this directory structure, and I am going to follow this directory structure. So it says that there should be 3 folders: board, configs, and package. Later I will explain meaning of every of this folder. And what more, it's 3 additional files. It's 3 additional files, and I will explain every file as well. So let's create these 3 folders. And 3 files. Okay, let's check. Yep, so we have 3 folders, and we have 3 files. First folder, it's a board folder, and in this folder I will keep several files and folders. I will explain you. First of all, it's kernel details. It's the same device tree file that we used for building our second bootloader. Then kernel config. Kernel config, it's a configuration file for Linux kernel. Then image ITS. Image ITS, it's a file that allows us to get image ITB binary file. I just remind you, image ITB binary file. So this file will combine compiled kernel, binary device tree, and archived rootfs file system. Post-image script. Post-image script, it's a script that will build image ITB file from image ITS by using MacImage. And rootfs file system. Rootfs file system, it's a file system. It's a file system that will be added to target's file system. So actually here we can set any files that we want, like for example kernel modules, or like any additional files. For example, interface where we can set our Ethernet static, or just for example I decided to create here image example txt file with hello from example file, and then when we load image ITB on our target, we will find this file in the user folder. Okay, so it's a board file. Next, configs. Configs, it's a directory where we can find Buildroot configuration file. So it's a Buildroot configuration file where we can set what desired packages, where we can set version of Linux kernel, where we can set where we are going to get our Linux kernel sources, where we can point where is our device tree file, kernel configuration, and so on and so on. For example, here you can set that you want to load onto your target and into your rootfs file system, OpenCV for example, or you can create your own package, and you can activate this package by using Buildroot configuration file. Also, we also in this file we will point where is our rootfs overlay and where our post-image build script. And please pay attention that here we have a variable. It's a global variable for Buildroot. So this variable allows Buildroot to find all necessary files, like for example kernel dts, like for example kernel config, and so on. We can where we should set this variable. We should set this variable in external desk file, and it will looks like this. So what does it mean? It means that our variable it's my dir, and this variable will be used by Buildroot like bear to external my dir path. Actually, a description of every of these files you can find in the Buildroot user manual, so feel free to use it. And for example, here you can find description of all these 3 files. Others 2 files, it's files for building our own packages. So it means that in folder package we can store our receipt, like for example kernel modules, like any application, and we should point to this receipt by using config.ini in external nk files. In this lesson, I want to show how to do this. Maybe in future, I will show you how to use all this file and package directory. Okay, so right now we are ready to build. For building our Linux image, we should go to tmp directory, and and in this directory we should set several commands. Like for example, okay, so first one, it's directory, and here we should point to our Buildroot sources. Zynq Linux image and Buildroot. Okay, then next path, it's part2 external, and here we should set path to our customization directory, Linux image, and this Zynq, okay, Zynq external. Then we should point to Buildroot devconfig, that devconfig configuration file that is situated in the our customization directory. mp devconfig. Okay, so and finally we should point where will be stored all our output files. So it's directly in tmp directory. Okay, so that's it. Sorry, I made mistake. Zynq mp devconfig. Okay, so let's see what we have in our tmp directory. Okay, so and then we just should run make command. It takes actually not several minutes. It can take half an hour or maybe an hour, because it will load all necessary files like Linux kernel sources, like for example tool chains and so on, all packages. It will compile all this stuff. So actually it's long. It's quite long. Okay, so our Buildroot has finished to build a Linux image. So here we can see executing post image script. Okay, and let's consider it. Let's consider all output files that we have in our TMP folder. For explanation, I will use Buildroot user manual, and okay, and here you can find Buildroot Quick Start. And yeah, and by the way, actually I forget to mention that before you run Buildroot, you have to install mandatory packages. So please pay attention to all these mandatory packages, otherwise you will not be able to build anything. And except all these mandatory packages, you have to install U-boot tools. Command will looks like this. Yeah, U-boot tools. Yeah, it's you have to install this package because it will run make image package that allows you to build image ITB file. Okay, so for explanation, I will apply for the Buildroot user manual and Buildroot Quick Start. So it explains Buildroot output subdirectories: images, build, host, staging, and target. So here you can find explanation of every of these directories. Okay, let's see. In our TMP folder we have all these directories: build, host, images, target, and staging. In images folder we have binary device tree, we have kernel, it's compiled kernel Linux, we have FreeFTS, CPU and LMA, and we have image ETB, which we are going to copy to our boot bin image. Okay, so just in short, I will explain some of these directories. For example, in target, in build we have built all our packages, like for example TSF agent, like toolchain, and here is a very important directory. It's Linux Xilinx, because it contains sources of the kernel Linux. It's very important because in future, if you are going to build any kernel module, you have to point to this directory. So just remember this directory. And another very important directory, it's a host in bin. Okay, here you can find toolchain. So it means that Buildroot downloaded toolchain. So you should use this toolchain again if you decided to build any kernel module. So you should point to Linux kernel sources and to toolchain. Of course, it's like cross-compiler. Then target, it's just a mirror. It's not our rootfs file system, but it's just a mirror file system that we will have on our target. For example, in user we can find our example file with a message hello from example file. Okay, okay, that's it about yeah. So our next step, we will add image ITB to our boot bin file and run this file on the target. So let's copy image ITB file, to the folder where we have all our previous files for system software Okay, just copy. And I have connected Zynq Ultrascale Plus target, so let me restart it. Okay, start and stop auto boot. Okay, so so what we have? We have target, and we already have downloaded our boot bin file, but it's file without image ITB. So we just download the system bin, untrusted firmware, PMU firmware, CSBL, and second bootloader. Yeah, so right now we have to load a second bootloader. I have Ethernet connected to my target and to my PC, so I just will use TFTP boot, TFTP boot 6 image ITB. So what does it mean? It means that by using TFTP server, I will load image ITB file into my RAM memory starting from this address. I have TFTP utility, and as you can see, yeah, it points to folder where is my image ITB file is situated. Okay, so it runs. Okay, so done. It means that we have right now our image ITB file in RAM memory starting from this address. Okay, so just let's boot from this address. Okay, our Linux start to boot. Okay, so finished. Okay. So first of all, let's config. Let's check. Yeah, so it's Ethernet static address that we assigned in our rootfs overlay. I just remind you. Sorry. I think board rootfs overlay interfaces Ethernet. Yeah, so this is the address. And then let's check about our file, example.txt file that we also have in our user folder. So and okay, let's. Yeah, so here we have example.txt file. We can see content of the file just by using WinCP. Okay, so this is a target file system, and let's run. Let's open user. Oh yeah, X. Okay, so it says hello from example file. Okay, so let's summarize all stuff that we had in our two previous parts. So, system software. System software is a set of files that we need for booting Linux on Zynq 7000, Zynq Ultrascale Plus. These files are, it's a first stage bootloader, it's a bitstream, it's PMU and untrusted firmware just for Zynq Ultrascale Plus, it's a second bootloader, and it's a Linux image that will include Linux kernel itself, compiled binary device tree, and the root file system. So, for building such files as first step bootloader, bitstream, and PMU firmware, I just used Xilinx SDK and Vivado. And by the way, and device tree as well. Then, for building untrusted firmware, second bootloader, I used cross compiler. So, Xanix SDK, Vivada, and cross compiler. I'm cross compiler for Zynq Ultrascale Plus. It's just was 64, and for Zynq 7000 34. ARM architecture 32. Sorry. Then for Linux image, I used Buildroot with out of 3. And by the way, actually, device 3 are common for second bootloader and for Linux image. Actually, in our next lesson, I will show you how to edit device 3, so we don't need to change device 3 anymore for second bootloader, so we can keep it the same. But for Linux image, for kernel, we have to change every time device 3. For example, if we decide to add some kernel modules, if we decide to change some memories and so on. So I just will show you in our future lessons. So I hope it was very simple. If you have any questions, please feel free and ask your questions.